The method I just outlined looks like this. Number 1, find the LCD of all the denominators involved. Number 2, we're going to clear the denominators by multiplying through by that LCD. Number 3, we're going to solve it. 4, so you can check your answer and make sure you get a true statement in the usual sense. But if you decide not to do that, like on a test, at least check to make sure you don't get division by 0. And that doesn't take very long. You can do that just by inspection, visual inspection. All right, part D, we have 3 divided by x squared minus 6x plus 9 plus x minus 2 divided by 3x minus 9 equals 2x minus 6, equals x divided by 2x minus 6. All right, I have to find the LCD. According to those steps above, I have to find the LCD. But before I find the LCD, what do I have to do? Let me make this a little bit smaller. Save some room here. We have to factor, don't we? We have to factor more than once. So how does x squared minus 6x plus 9 factor? Yeah, I mean, you could use reverse FOIL, and very quickly you'll see that, oh, it's a 1 here, so good news. It's the more systematic method. You need two numbers whose product is 9 and whose sum is what? Negative 6. So it's got to be what? Minus 3 both times, right? Do you want to write it that way? I think for finding common denominators, it's better to write it as x minus 3 quantities squared, because then if you have more than one power of x minus 3, remember, you take the higher power of it. And so you don't get extra factors. You want the LCD, and you don't want to mistakenly take just x minus 3 one time. You need to take it twice, which means x minus 3 squared. Okay, so how does the next denominator, 3x minus 9, factor? And then, so GCF, right? And then what's left? X minus 3. And then the next denominator? GCF is 2, x minus 3. Well, okay, the LCD is not too hard to find, is it? So the LCD is going to contain the higher power of x minus 3, right? So it's got to contain a factor of x minus 3 squared. What else? Okay, it's got to contain a factor of 3 and a factor of 2, right? So 3 times 2 is what? 6. Everybody see that? How I got that? Okay. So then I'm going to multiply through by that LCD. So I'm going to multiply the left-hand side by 6 times x minus 3 squared. I'm going to multiply the right-hand side. I'll do it on the right. It doesn't matter which side you do it on. By 6 times x minus 3 squared. Question?
Okay. How did you get the 6 again?
When you form the LCD, remember, the LCD has to contain all the factors of each denominator, and it's the smallest polynomial that does so. So it's got to contain a factor of 3, and it's got to contain a factor of 2. And so if you were going to write it out, remember what you do. To form the LCD, you take the product of those factors, but when you write out the 2 times 3, you get 6. Yeah. Okay. So another way to think of it, by the way, is for the numerical factors, it's the same as finding the LCD for just numerical fractions, right? So if you were adding like 1/3 and 1/2 together, the LCD would be 6. All right, so now I'm going to try to skip that step where I show the distribution here. If you don't want to skip that step, don't. But I think we can get comfortable if we try it doing this step in our heads and then just writing down the cleaned up version of it. So just think about what you would have if you distributed this. This would be in the numerator here as a factor, and okay, put parentheses around this, and over here as a factor, wouldn't it? So think about what would go away from this first term and what would stay. Wouldn't this denominator go away altogether when you multiply, when this guy, wouldn't it cancel with this guy, which would be in the numerator right here? Wouldn't the x minus 3 quantity squared totally go away? What wouldn't go away? The 6. What's 6 times 3? 18. So if you can do that in your head, it's better because it's cleaned up, right? 18, that's a lot better looking than having 3 times 6 times x minus 3 quantity squared all over x minus 3 squared. That's a mess when you write that on your paper. But some people prefer that step, and I'm not gonna say no. I want you to do whatever, show whatever work you need to get the right answer. Okay, now let's think about the second term. What's gonna stay? What's gonna go away? So certainly the whole denominator should go away, right? So you can start, you can cross this guy out. It's gone, but you got to compare it with this guy and see what's left from that. So certainly the original numerator is going to be left, right? That's not going anywhere. X minus 2, and then certainly you'll have one factor of x minus 3 left, right? And then you've got to deal with the 3 here and the 6 here. How are those guys going to interact? 3 goes into 6 twice. Yeah. Okay, does everybody see that? Any questions on that? Okay, and then over here, what's going to happen here? 2 goes into 6 how many times? 3. And then one of these will cancel with one of these. So what do we have left? 3 times x, everything's multiplication, right? So 3 times x times 1 factor of x minus 3. Would you agree with that? Does everybody believe that? I will take your silence as a yes. Okay, so now we've got it down to something that's not nearly as bad. There's still something we have to do on the left side and on the right side before we can combine like terms, right? You're going to have to multiply things out. All right, so here's how I would do this guy. I would multiply this guy out, leave the 2 outside, put in a set of parentheses, and just FOIL out the x minus 2 times the x minus 3. Okay, so let's think about that. What would that be? So first times first gets you x squared. Okay, and then if you want, you can do the outer and the inner together. So what does the outer give you? Negative 3x, and the inner? Minus 2x. What do those combine together to be? Minus 5x. And then if you multiply out the last terms, what do you get? Positive or negative? Plus 6. Any questions there? I'll multiply out the 2 in the next step. Any questions there? Okay, and then go ahead and multiply out the right-hand side. What do you get? 3x squared from that multiplication, and then you're distributing, right? So minus 9x. 18 plus distribute the 2, what do you get? 2x squared plus or minus? Minus 10x plus 12, and then the right side doesn't change. Yes?
Can you still get the same thing if you already added 18 and 2?
You can't, you have to remember the order of, please remember your Aunt Sally.
Yeah.
Please excuse my dear Aunt Sally. You have to do the multiplication before the addition there, right? So get rid of the parentheses before you add. Okay, so now let's combine the 18 and the 12, though. What do we get? So we still have 2x squared minus 10x. 18 plus 12, 30 equals 3x squared minus 9x. Ooh, we're almost there. We're getting there. So we're working towards setting it equal to 0. So what can I do at this point? I don't want to factor yet before I set it equal to 0, right? Oh, no, yeah, no. I don't see a way around that. We got to set it equal to 0. So I like to keep the coefficient of x squared positive. So how could I keep the coefficient of x squared positive? What could I do to both sides? Huh? Move to the right, yeah. So my idea is this, you guys. We could go ahead and take 2x squared from both sides, line it up with its like term, and then I might as well move the 10x over by adding that, line that up with its like term, and then subtract the 30. Or you could have moved the 3x squared and the minus 9x to the other side and then multiply through by a negative, and you'll get the same thing if you wanted to move less things. So, okay, all of these guys are gone. We get 0. And on the left side, what's left on the right side? X squared plus x minus 30. Question?
I just wanted to know where you got the 30 from.
The 18 and the 12 combined. So we added like terms, yeah. So then what's the next step on this one? Yep, we got to factor this thing. So good news is there's a 1 in front of the x squared. So we set up our two parentheses. Our first term have to be x and x. And then we want two numbers whose product is negative 30 and whose sum is 1. Okay, so yeah, I'm thinking 5 and 6. One of them has to be negative, so minus 5 and plus 6. Everybody believe that? Okay. Now, what do we do with both factors? Set them equal to 0. Either x minus 5 equals 0 or x plus 6 equals 0. And then what do we get? X equals 5 or x equals negative 6. Now, I'm not going to have time to check these, but you could check them, again, using a calculator. If you know how to plug into a calculator, you could do this. You do want to look and make sure what don't you want to have for an answer. What kind of answer would be extraneous? Yeah, but what answer would give you 0 in the denominator? Look at the factored form. Let's go back. Let's go back to the factored form. It's kind of a mess here, but what did we have? We had x minus 3 quantities squared, x minus 3 right here, x minus 3. An answer of 3 would have been bad, right? It would be extraneous. Do we have an answer of 3 there? No, so my bet is both of those are going to check. Okay?